Okay, so we're going to do another problem from page 268. We're going to do number 29, and this is again going to show the domain, the range, and then the x intervals, so the x values where the function is increasing, decreasing, or constant. And then we're going to find some specific values, f of 0, f of -2, and f of 2. So for number 29, very similar to how we did number 26, we're just going to evaluate it. These arrows mean that it just keeps going on and on and on off of the graph, so we need to take that into consideration. So starting off with just the domain. So the domain, once again, is just going to be all the possible x values that you can find on this as coordinates on this graph. So since it just keeps going on and on and on in this direction, in the negative x direction, we say that our x values are going to move to negative infinity essentially. Every negative value will have a corresponding x coordinate on this graph at some point. It might be later on, down the graph, like it might, continue on and on and on forever, but every single x value along the x-axis, even when it gets off of the page here, is going to have a corresponding coordinate. Okay, so similarly in the positive direction, since this arrow just keeps going on and on and on, there's going to be a corresponding x value all the way through that. So that means that our domain has all the negative numbers, all of the positive numbers, so it's going to be all of the real numbers, or if we want to write it up in interval notation, negative infinity to positive infinity. Okay, so that's the first part of it. Now let's look for the range. So the range is going to be all of the possible y values that we can get on our graph. Okay, so once again, going back over to number 29 here, the graph just keeps going up and up and up and up and up forever. So that means that along the y-axis, we're going to have corresponding y values all the way through, basically for positive infinity. Same thing in this direction. We've got an arrow, so it's pointing downward, so it's going to keep going down and down and down through this graph. So that means that if we look at the corresponding y values along the y-axis, we're going to have corresponding points all the way down the y-axis. So that means that once again, we have all the negative numbers and all the positive numbers positive, so the range is also going to be all real numbers. So two pretty easy ones so far. Now let's go ahead and take a look at the intervals where it's increasing, decreasing, and constant. Okay, so remember that increasing means that it goes up and to the right. Decreasing means that the graph goes down and to the right. And then constant means that it doesn't go up, it doesn't go down, it just stays horizontal as you go from left to right. So we start on the left-hand side of the graph. It looks like we start off by increasing up to the right, up to the point of -3. Now, here's kind of like a challenging part for you. You got to imagine that like if you have this little arrow here, then that means that the x values continue on and on and on in that direction using the same pattern. Okay, so what that means is that we start at negative infinity for this interval, and we go all the way up to -3. Now, if the graph looked a little bit different, like if, let's just say that one part of it looked like this instead, where we had the arrow pointing this way, and we're going this way, like this, up to a certain point, then that means that the graph starts by going down and to the right. So that means that this would be decreasing from negative infinity all the way down to this point, wherever that is on the x-axis. But this graph is a bit different. Do you see? Like, so from the arrow, we start off by going up and to the right. So if we're going up and to the right, then we're increasing. So basically, like, it's going to continue increasing all the way from negative infinity up to this point. That's what it's saying. So that means that we have one interval of increase from negative infinity all the way up until that point, -3. Now you might notice that, when I do the intervals of increase, decrease, or constant, even back over to the previous example that we have, I always have parentheses. This is going to be true for every interval of increase, decrease, and constant when we write it up. All of our intervals will always have parentheses on them if we want to write them up in interval notation. Okay, so we continue on with the graph. So when it starts at -3 here, now we're going horizontally. So from -3 up until the x value is 4, it's going to be completely constant. So a horizontal line right there from -3 up to +4. And again, parentheses around those x values. All right? And then when we get to 4, and then for the rest of the graph, in other words, for all the rest of the positive x values, it's going to be increasing again, going up and to the right. So that means that we have another place where it's going to be increasing, and that starts at 4 and goes all the way to positive infinity. And remember, when we have two intervals like this, we want to combine them together with a union in between. So where is it decreasing? Where is it going down and to the right? Well, it doesn't look like it is at all. It's going up and to the right here. It's constant here where it doesn't go up or down, and then it goes up again. So there is no down and to the right on this entire graph. So that means that we just say that there are no intervals where it's decreasing. We can write the no solution symbol there, or we can just write the word nowhere. Is it decreasing? Something like that, just to get the point across that it's not decreasing anywhere. Okay, and then we have to find the same function values, f of 0, f of negative 2, and f of 2. So for these ones, we just say that x is 0, what's the y value? That's basically what it's asking. So on our graph, it looks like if we look for where x is 0, that'd be right over here. The corresponding y value is going to be 2. So that means that when when x is 0, that means f of 0 is going to be equal to 2, or the y value is going to be equal to 2. Because remember, they kind of mean the same thing. Next, f of negative 2. So we got to see where x is equal to negative 2 on our graph. So we go to negative 2. And it looks like at negative 2, when x is negative 2, it still is part of this constant line that we have over here. So when x is negative 2, y is also going to be 2 again. So this is going to be equal to 2 as well. Now let's see what happens when f of 2 is, what happens with f of 2. So we go over to when x is equal to positive 2, and it looks like it's still part of that constant line. So that means that when f of 2 is calculated, it's going to be equal to 2 as well. So those are all three of the values that we're going to get from here. And that's it. That's part A, part B, part C, part D, part E, all that stuff. And that is, yep, that's it. Okay.